welcome to the Jack Westin MCAT podcast with your host, Ahmed
and Eric Olson.
Welcome back, everyone, to another episode of the Jack Westin MCAT podcast with Ahmed and Eric. Today, we're going to be looking at redox chemistry in the context of organic chemistry. So looking at alcohols, aldehydes, carboxylic acids, the oxidizing and reducing agents that sort of facilitate the conversions between them, and then looking a little bit at the carboxylic acid derivatives as it pertains to different biomolecules that we want to be familiar with. But Eric, anything new on your end before we dive in here?
I finished my first full week of residency started, or not residency, but categorical program, dermatology, started on a Monday, July 1st.
Yeah.
We had some orientation time and stuff. And so this second week has been my first full week of seeing patients and stuff. And I don't know if I really have anything to report. It just feels like a milestone, we went out to dinner last night and it was we made it through a week, a full week of being a doctor and doing dermatology and stuff. So that feels good. I mean, it's just a lot of learning. And honestly, I haven't even really touched the skin medicine yet. It's just how do I work the computer? There's so much of that you have to learn. So
Right.
It's been a week. What about you? How have things been going?
Things on my end
I wanted to ask you, on the getting ready for med school scale, are you scaling up and doing things and getting ready right now, or are you just kind of just pushing it off? Don't have
honestly, no. I was telling a buddy of mine, I've got these registration things to get done, and I'm nowhere near done.
Yeah. A lot of paperwork.
What's that?
A lot of paperwork.
It's not even paperwork. It's these online modules you have to do. And then I gotta get my immunization thing done. And so I have to do 4 visits to my doc to get 2 rounds of TB testing. And then the worst thing, and this is the thing that's really gonna screw me, is I have my first aid course that I've got to get done. And so it's a 2-part course. It's you have the it's hybrid. So you get the virtual part done first, and then you can do your in-person part. Each segment takes 8 hours. The virtual part takes about 8 hours. You don't have to do it all in one sitting, but it takes about 8 hours. And then you have the one in-person day from 9 to 5. My in-person day is on Thursday, and I haven't even touched that course yet. So I gotta really get going on that this weekend. But typical procrastination, we'll say.
Is that a CPR course?
Yeah, it's standard first aid and CPR. I think level C is what it's called.
Okay, I don't know what that is, but it sounds
yeah, and getting that done. But in terms of readiness for school, I think, I was telling a friend of mine the other day, I've been out of school for a year, so I haven't had any tests to get ready for or anything like that. And I've always kind of thrived in that environment.
Yeah.
So that'll be exciting. I think the big thing for me though is I'm going to be the new guy on campus for the first time in 10 years, because I went to high school in the city. I went to college in the city. I went to high school where I live.
Yeah.
And granted, you meet new people in college, that's 100% sure. But, I went into college, already knowing a lot of people, because I've lived in the city and then I played varsity sports. And, but now I'm going to a new city where, number one, it's a much bigger city. And number two, I don't know as many people in the city. And so I'm excited to just kind of be anonymous and, just do my thing. But as far as being ready for school, this might sound bad, but I'm not really worried about school. The first year, at least in this program, isn't all that bad. It's if you got to difficult or challenging undergraduate degree in any capacity, like usually the transition's not too bad.
Yeah.
For me, it's more so like I'm just excited to get back to school and then just move. Like once the move's done, I'm fine.
The worst part. Yeah.
Yeah, but it's like it's not a huge move, and I'm not taking a ton of stuff. Like I just gotta assemble like my bed like box, and just like get the stuff like into the room, and then you know it'll be fine.
Are you going to be living pretty close to the school?
It's a half-hour walk, 10-minute bike ride. So
that's perfect.
Yeah, not bad. I ended up getting an e-bike, so I'm not gonna take like the public transportation or anything. And so yeah, it's cool because like Toronto is a huge city, and campus is kind of like on the northish end of the city. Downtown's on the southish end. And where I'm at is kind of like in the middle. So yeah, it's sweet. It's I'm looking forward to it.
That's awesome, man. I'm excited to hear about it. I remember we did, and I'm sure you do a similar thing, but like we would have these meetings with like a faculty advisor, and we had to like come up with goals of what we wanted to accomplish that year or over the 4 years or whatever.
Right.
And I remember like similar to what you're saying, you're like, I'm not really worried about the school part. Like I'm okay with school. I'm good at school. And that's how I felt. So I was always like, my goals are like to learn how to, like talk to people, make them feel comfortable and like ask the right questions. Because I think I can learn the science, I can learn the medicine, but it's the art of medicine that I want to get good at. So I resonate with that. The school stuff will come, like you'll spend time studying and you'll learn those things. But anyway.
Yeah, no, it'll be a learning experience for sure. Like I'm sure there'll be some trial and error in there, but that's really anything in life. I feel like
that's how it goes. Yeah.
But yeah, man. No, excited for it for sure. But in any case, one of the things that I won't have to be studying in med school is O-chem, which yeah, not sure how I feel about that because actually, I didn't hate O-chem. Mainly, and I really do mean this, mainly because I had a really awesome professor when I took O-chem in college. And like he was just this is a true story, I swear to God. And I remember telling a buddy who I missed it, he was mad. And justifiably so, but I'll tell you the story and then you guys be the judge of how great this professor was. So I was this would have been like the winter term in 2021. So like the second semester of the 2020-2021 academic year. I had taken O-chem 1 with this professor and I'm now wrapping up O-chem 2. It was an online exam and that's an important detail to note. Because like you're just scrolling through questions, right? And so he had put out a couple of practice exams for us to work through to get ready for the exam, and they had various numbers of questions, 53, 51, 52, etc. But all of our tests had always been like that, at least that year, even in O-chem 1 had always been 60 questions. For whatever reason in my mind, I got wired into the exam is 53 questions, even though like it very clearly like in the like pre-exam announcement said it's going to be 60 questions.
Yeah,
that wouldn't have been an issue if as I finished number 53, 54 was right there, right? Like I would have been like, oh wait a minute, hold on, it's not 53 questions. But to my we'll say for my luck 53 was at like the end of a page.
You had to turn the page.
Well, there's no page to turn because it was on a computer.
Oh, right. Okay.
And so if it was a physical test I would have seen that there's still pages.
Yeah.
So I ended up not doing 7 questions. And so
pretty good chunk of 7 of 60. It's like more than 10%. Right?
That's almost 12%. Yeah. And the catch here is that my exam was worth, I believe, 60% of my final grade because of the 3 like midterms. I didn't do one of them.
Mm-hmm.
And like we had that option. Again, speaking of how great this professor was, like, hey, 3 midterms. If you don't do one of them, I'll just throw it on your final exam. I'm like, hey, okay, cool. I'm not doing that one.
Yeah.
And so I'm like, wow, this is not good. Because like 12% of like basically, or no, sorry, my exam was worth 80%. Because I remember I was gonna lose like close to 11% off of my final grade.
Yeah.
Just from not doing the 7 questions. And I was just, and I, the funny thing is, I found out through the most awkward conversation. I was talking to a friend of mine who, we were just talking about the exam. Like, she did not love this exam. And I was like, hey, you know what? Listen, you did your best, and this guy's great. You might curve it, like you might make it out of 51. Mm-hmm. And then she's like, you think they'd really like reduce the number of questions that much? And I was like, what do you mean? It's only 2 questions. She's like, I don't know what exam you wrote. But mine had 60 questions. And I was like, did it now. And so I emailed him, and he was, he just kind of like, obviously I couldn't see him, but he gave me like this disappointed dad email. And it was just like, listen, normally people miss like 2 or 3 questions on 1 or 2 pages. You missed 7 questions on 5 pages.
Oh man.
But he ended up just marking the 53 questions that I had done.
Yeah.
And I ended up doing very well in the class. But like he easily could have just like tanked me.
Yeah.
But anyway, so yeah, all that to say, I had a positive experience with organic chemistry in college, which not everyone can say the same, but I was very, very fortunate. And this guy was just a very good teacher. Like he explained things clearly, and a lot of what I learned did carry over into the MCAT. But we're going to try to maybe replicate that level of teaching today. And I think a good place to start, a good place to start is just understanding and an easier way to think about redox in the context of organic chemistry. We all know redox is a transfer of electrons. Not the easiest thing to visualize, though, in organic chemistry, right? In, we'll say, Gen Chem, you can look at oxidation numbers, and it's a little bit easier to track, okay, this one gained an electron, this one lost an electron, etc. With redox, it's not, or sorry, with O-chem, it's not really that straightforward, and a much easier way for me anyway, and for what I've taught my students is just look at bonds to oxygen and bonds to hydrogen.
Yeah.
Okay. You only need to remember one thing, and the rest takes care of itself. Oxidation, more bonds to oxygen. Everything else is opposites. So if oxidation is more bonds to oxygen, that means less bonds to hydrogen. If oxidation is more bonds to oxygen, that means reduction is less bonds to oxygen. And if reduction is less bonds to oxygen, that means reduction is also more bonds to hydrogen. Done. Very similar way to like how I remember like resistors and capacitors in series and parallel. The one that makes the most sense, resistors in series are additive. Everything else is opposite. Parallel is reciprocal, and then you deal with the capacitors. Yeah. So that's one thing that I think is really, really important is look at bonds to oxygen, look at bonds to hydrogen, right? And the bonds to hydrogen tell you how many times something can get oxidized. For example, if we look at a tertiary alcohol, right, you have your OH connected to a carbon, which is connected to 3 other carbons, right? So that would be tertiary. No hydrogens on that carbon that's attached to the OH. So it can't get oxidized at all.
Because you can't lose any hydrogens.
Exactly.
Yeah.
Secondary alcohol, right? Now we're attached to the OH and 2 carbons. That means there's 1 hydrogen. This can get oxidized 1 time. Primary alcohol, 1 carbon attached to the carbon attached to the OH. So there's 2 hydrogens there. That gives us 2 oxidation steps. which is why we can go all the way up to a carboxylic acid. And technically speaking, we might get into this a little bit later, but technically you could oxidize that a third time and take it all the way up to carbon dioxide, which is like the most oxidized form of carbon, because it has all 4 bonds being 2 oxygen, and that's our end product in cellular respiration, right? Carbon dioxide, the most oxidized form of carbon, to produce as many electron carriers as possible that we can leverage for energy. But I'm curious, Eric, like when you were studying for O-chem, especially like this specific stuff like alcohols, aldehydes, ketones, all that stuff, was there another way that you conceptualized it, or what was your process like in trying to understand this pathway?
Well, I want to just say before I answer your question that I love what you just said, which is you bring in like cellular respiration and say like carbon dioxide. That's like the most oxidized form. This is like the end product of cellular respiration. If you think about it, like we can't have respiration without intake of oxygen, right? So like you could honestly call it cellular oxidation, and like you're oxidizing things until you get to the point of carbon dioxide, right? So just bringing that into like metabolism, I think is a great tie-in, something to be aware of. O-chem is like an interesting part of the MCAT, I think, and I had a good experience with O-chem as well, but I think that it's kind of polarizing, right? Like people either love it or they hate it. And what's interesting for the MCAT is, well, I don't know what your class was like in undergrad, but mine was like a lot of pushing electrons. Like I want you to show your work, like show the arrows. And that's why I said, why didn't you just turn the page? Because the exams that we would take were on paper, and it was like they like graded them all individually because they wanted to see your work of like where you were drawing your arrows of this electron going here and whatnot. And so like maybe you're really good at that and maybe you suck at it, and it just doesn't really matter for the MCAT as much. Like you don't need to push electrons for the MCAT for the most part. There might be one question here or there very infrequently that you need to like really think through a mechanism of what's going on. But when I was thinking through these sorts of concepts for the MCAT, I think like there are certain things that you can just memorize, like some of the stuff that we're talking about today of like, what is the oxidation pattern of a primary versus a secondary alcohol? Like if you knew how to push electrons and do organic reactions and you had never seen it before, like you could figure it out. You could figure out what that oxidation looks like. But for the MCAT, you don't need to. So you can just memorize, like, if I have a primary alcohol, it's gonna, and I present an oxidizing agent to it, it's gonna oxidize to an aldehyde and then to a carboxylic acid. That's what you need to know. And then I think, like having an understanding of some of the more basic principles and how they might contribute to organic reactions, like what are the electronegative atoms, like which part of this structure is a nucleophile, which part is an electrophile. Like a carbonyl carbon, for example, is very electron poor, right? So if you have an electron rich molecule in some part of a molecule, then that can attack a carbonyl carbon because it is an electrophile. Like those sorts of things I think can be helpful because it can help you to predict structures. But again, there's just not a lot of that on the MCAT. And so it's helpful to know, but I wouldn't say it's like my top thing. Like if I'm going to study 5 things for Chem Phys, organic chemistry is probably going to be a little bit lower on the list. But I don't know, Ahmed, what do you think about that? Am I in the wrong? It's been a few years since I took the test. So.
I think you're right about the arrow pushing stuff, especially for redox. I think it can be helpful with SN1, SN2 stuff.
Sure.
Especially SN2. SN1 is a little bit maybe easier to follow. Something leaves, something joins later. I think it's also helpful in understanding like the synthesis of some major biomolecules. Like if you talk about like making a peptide bond, being able to push your electrons can actually be a little bit helpful. Like seeing the lone pair on the amine go into the carbonyl carbon. I don't think it's necessary to do well on the MCAT by any means. I think if you have that background, though, it can make it easier to recognize what's actually happening in a reaction.
Sure.
On the notes of like electrophilicity, nucleophilicity, I think that's definitely testable. And you'll see it asked in somewhat similar ways to what you might see in college. For example, if I add an acid catalyst to a carbonyl mixture, right, I'm going to protonate that oxygen. Now the carbon's even more electrophilic, so this is speeding up the rate of the reaction, right?
Yeah.
Those are the kinds of things that you do want to take from O-chem. You don't, and like I don't think I ever learned like the electron pushing mechanisms for like oxidation. Like that was just like you never needed to know like how that happened, or if we did, it was just like our professor called it FYI. Like it's just for your info. It's not testable, so it's definitely not testable on the MCAT. But yeah, I think like just in terms of like nucleophilic attacks, the electron, just being able to follow where the electrons are going can be helpful. But like you said, it's not a critical thing to know. There's one passage from one of the AMC exams in particular that I can remember, and it's just an O-chem mechanism that's like 9 steps.
Yeah.
And like 6 of them are like things that you could actually like figure out.
Interesting.
And it's not always immediately obvious, but if you have an O-chem background, it makes a lot of sense. For example, and I don't want to give away too much, but in one of the steps, I believe there's sodium carbonate added, there's hydroxide added, and then it's heated. Or no, sorry, I'm combining 2 steps. Just sodium hydroxide and heat, let's say. And so what ends up happening there is the hydroxide hydrolyzes an ester, turns it into a carboxylic acid, and then heat actually promotes decarboxylation. So in the next step, this entire ester group was just completely gone.
Yeah.
And so like that's something that I could see, and I can say, oh yeah, I know why this happened. And so I would be comfortable with like some of the like major things in O-chem, but again, like I didn't need electron pushing to piece that together.
Let me ask you. We'll get into the oxidation of alcohols a little bit more in a minute, but what would your advice be to a student who maybe did not have a great O-chem experience like we did, and is feeling like I don't know a lot of this stuff, and it's like I'm having trouble teaching myself all of these concepts. Like, where would you start? How much would you emphasize it?
Yeah, that's a good question. The good news is MCAT O-chem is easier than college O-chem. There's no debating that. Like, it is an objective statement of fact. Especially if you've taken multiple semesters of O-chem, like 20% or less of what you covered is going to be on the MCAT. I think really like O-chem on the MCAT falls into like 4 categories. There's like what I'll call like the O-chem basics, which are like nomenclature, functional groups, and like different types of bonds, right? Sigma and pi bonds. There's, the alcohol, the carboxylic acid pathway, including carboxylic acid derivatives. There's SN1, SN2 reactions, and there's like lab techniques. So spectroscopy, NMR, all that stuff. UV vis is another one. And so I would just start with one of those sort of clusters at a time. And even if that's like the foundation, like get the ball rolling with something a little bit easier that can boost a little bit of positivity. In terms of the other stuff, like as we'll talk about today, like you can simplify, the alcohol, aldehyde, carboxylic acid stuff really into like a 15 to 20 minute mini lesson. And that's one of the great things in our course actually is I filmed a workshop literally just on this exact topic. And so if anyone's listening to this and like, I'm like really struggling with this topic, just connect with an academic advisor and we'll set you guys up with a 5-day free trial of our course. So you can watch that plus any other video you want. for a whole 5 days. I think the biggest thing though, and again, everyone's a little bit different, but for me, I was a very visual learner. So just like seeing things on paper and saying, oh yeah, this has more oxygens than this, so this is oxidized, and then you do it again. I think it was big for me. But at the same time, I think one of my biggest skills was recognizing when something just doesn't click, right? I'm not going to try to fit a circle into a square, right? Instead, I'm just going to try a different approach. So if watching this video 4 times has not done the job, I'm not going to watch it a 5th time. I'm going to look for a different video or a different resource, etc. So yeah, to summarize, I guess, a shorter answer to your question, number 1, just understand it's just 4 main topics. Number 2, trust that it's going to be easier than what you learned in college. And number 3, if something's not working, that's okay. Do your best. And if it's not like helping, try a different option. And I can pretty much guarantee all the students listening that like there are great resources out there to really simplify O-chem on this exam.
I love it. It's daunting, I think, but it's good advice on that. And I think there are a lot of daunting topics on the MCAT, and you just tackle them one by one.
Yeah. No, honestly, like that was the summer I got hired here. That was basically like my job was film workshops on the hardest things and make them easy.
Yeah.
Like, okay.
I feel like I should have done this before the MCAT. I would have been that much more of an expert when I took the test, right?
And it's funny you say that. I kind of understood fluids when I took the MCAT, but I didn't really click for me until I had to prep for that workshop, and I was like, oh my god, it all came together.
Yeah, teaching is really the best way to learn things like a pro.
Time. And that's why like as of like the past several months with tutoring, like I will make my students like explain things back to me, even if it's over email. Hey, go like revisit this topic, teach it back to me in your own words.
Yeah.
And if I'm not happy, I'm gonna make you do it again.
Yeah.
Because like you said, like you teaching something to somebody else, hands down the single best way to learn. And I remember in college there was this software that we used. It was called Critic. And basically what Critic is you would make an assignment and your peers would evaluate your assignment. So it was really cool because you'd get like free participation points and all this stuff, but you submit an assignment and then you would grade 3 other assignments. And so in grading the other assignments, number 1, you're exposed to more work, but you actually have to understand what's right and wrong to be able to say, hey, I'm going to give you this grade out of 5. And so, but it was also, it's a cool software because you might be thinking, well, if your grade is influenced by, other people, like that kind of sucks. Well, you get like these accuracy points. Basically, the more closely you grade somebody relative to the average of the 3 evaluations, the higher your evaluation score goes, which means going forward, you have a bigger say, like your score is a bigger weight in the average.
Yeah.
And it was an awesome software, like really
interesting.
But in any case, definitely teach, explain things to your friends in simple terms. I think it's such a great way to consolidate information, and it makes things a lot easier to understand.
Yeah, and I agree. If you don't have a study partner, at least find someone you can partner up with once in a while to teach some of these harder topics, because it kind of exposes you, like you said, and like you can't hide when you're trying to explain or teach a concept. You have to know all of the steps and all of the pieces and be able to explain away, any questions that someone has. And so you really have to know things. I just love the idea of doing, I don't think anyone would ever do this, but like exactly what you did, like film yourself, for like future generations of MCAT studiers, film yourself in these concepts, because, if you know what's going on the Jack Westin MCAT website, then you're not going to be messing around,
Yeah, no,
you're going to know what you're doing.
Gotta put my best foot forward. It's going in the time capsule.
Yeah, exactly.
But in any case, as far as the alcohol to carboxylic pathway, I think, to recap what we've done, discussed so far, the alcohol is the most reduced or least oxidized form, right? And then if it's a primary alcohol, it'll form an aldehyde as its next step. If it's a secondary, it'll form a ketone. Tertiary can't get oxidized. With the ketone now, we're out of hydrogens. This can't be oxidized further. The aldehyde can get oxidized one more time to a carboxylic acid. And usually that's as far as the MCAT goes. But again, understand that you can heat the carboxylic acid to promote decarboxylation and make carbon dioxide.
You make that a leaving group. Yeah,
exactly.
I'll jump in briefly, Ahmed, and just reiterate that kind of what we're looking at here is it's like a push and pull between oxygens bonded to carbon and hydrogens bonded to carbon, right? If you're going to reduce something, you have to find, it doesn't have to be an oxygen, right? But in organic chemistry and the biomolecules that we're talking about, usually it is an oxygen, right? If you're talking about oxygenation or oxidation, excuse me, then you're looking at how many hydrogens is this carbon bonded to? Because in order to have another bond to an oxygen, something has to leave. And it's usually going to be a hydrogen, again, at least in these scenarios that we're talking about. And so, when you say, if you have a secondary alcohol, means it's bonded to 2 carbons and 1 hydrogen and 1 alcohol group. And you said, we can oxidize it once. One of those hydrogens will leave, or the 1 hydrogen will leave, and you'll get a second bond to oxygen. So it will create a ketone, a double bond to oxygen. And then you have a carbon that's double bonded to oxygen and bonded to 2 carbons. You have no more hydrogens left, and that's just another kind of illustration of that's why we're saying you can't oxidize it any further.
Right.
You have no more hydrogens that are bonded to the alpha carbon that can leave and allow for another bond to oxygen to be formed. And that's why we can have multiple steps of oxidation with a primary alcohol, because you have so many hydrogens that are bonded to that central carbon that can act as leaving groups. And that's why we can't have any oxidation with the tertiary, because we have no bonds to hydrogen that can act as leaving groups. And, the same thing applies when we're talking about it in reverse. Like when we're talking about reduction, then you're looking at, I'm going to break a bond with oxygen and I'm going to add a bond to a hydrogen. And so then it kind of comes down to a discussion of like, what reaction are we looking at and what are the reagents that are parts of these reactions? And so what kind of reagents are we looking at that are oxidizing agents versus reducing agents? And like, how can we recognize those things? Are there any like in particular that we need to know and be familiar?
Yeah, there's 4. And what's nice is that there's some parallels. Like there's one strong reducing agent, a group of strong oxidizing agents, 1 weak oxidizing agent, 1 weak reducing agent. Mm-hmm. So the weak oxidizing agent is called PCC. Couldn't tell you what that stands for. I think per is something. Doesn't matter.
PCC.
Yeah. And so PCC, you're taking alcohols, making carbonyls, and that's it. It can't go further with an aldehyde.
Mm-hmm.
And so they can't take an aldehyde into a carboxylic acid.
Because it's a weak oxidizing agent.
Exactly. And so if you're trying to make an aldehyde, you need to use PCC. Otherwise, these strong oxidizing agents will go straight through to the carboxylic acid. Literally anything else is a strong oxidizing agent. So chromate, permanganate, those are usually the main 2. But yeah, anything other than PCC is a strong oxidizing agent, which is nice.
And if you look at those 2 that you mentioned, chromate, permanganate, like they have a ton of oxygens on the structure, right? So like it's pretty intuitive that you're thinking like this is an oxidizing agent, like it's adding an oxygen or it's going to take away a hydrogen or a proton. And so I would, if you were to see something where you're suspecting a redox reaction and there was, a reagent that they added that had a bunch of oxygens on it, like you could probably fit that into the group of strong oxidizing agents. I don't think that's very likely to happen. But that's kind of the pattern that we see, right? It's like when there are a lot of oxygens present on this reagent, then it's likely to be an oxidizing agent.
Correct. Yeah. And to that note, I couldn't tell you what PCC looked like, but you don't need to know. You just need to be able to recognize it. One other thing I will note. I don't think I've seen this on the MCAT, but there's also the Jones reagent,
Mm.
which I believe is just a version of chromate, if I remember correctly. So strong.
Yeah.
That's the only other thing that came to mind there. But like, I don't think I've ever seen that on the MCAT. I have seen PCC. I have not seen the Jones reagent. So, just consider that FYI until otherwise stated. On the reduction side, sodium borohydride is very analogous to PCC in that it's a weak reducing agent. It will take aldehydes and ketones back to alcohols, but it can't touch carboxylic acids or their derivatives.
And that's sodium borohydrate? So is it like NaBH3 or H4, something like that?
BH4, exactly. Yeah.
BH4. Okay. So a lot of hydrogens, right? A reducing agent has a lot of hydrogens.
And it's specifically the hydride because it's the hydrogen with 2 electrons now.
Yeah.
It's the hydrogen anion, which is extremely an extremely good reducing agent. It really wants to get rid of that extra electron because if we think about why, right, we're squeezing an extra electron into this tiny hydrogen atom, right, which is much, much different than squeezing a hydrogen into a fluorine, like much different. Sodium borohydride, weak reducing agent. And then lithium aluminum hydride, so LiAlH4 is a strong reducing agent. It'll take carboxylic acids and esters all the way back down to alcohols.
Yeah. Beautiful. I love it.
That's really it with the redox. Like that's all there is to know.
Of alcohols, right?
Like alcohols, aldehydes, carboxylic acids, like that whole cluster there. Really it. Like we'll get into carboxylic acid derivatives here in a second, but like that's literally it for this chunk.
Yeah. There's an interesting reaction that like there's not a lot of O-chem in medical school, although there's you have to know it. Like there's a reason you have to know it. But there is one like reaction that comes up in medicine, and it is like methanol drinking. So like ethanol is 2 carbons and an oxygen in an alcohol group, and methanol is 1 carbon in an alcohol group. And so methanol is present in like, I think it's like, I want to say it's like windshield wiper fluid and some other things. And like, it maybe gets you a little bit drunk. And so people who like alcoholics who don't have access to alcohol will sometimes drink methanol to try to get drunk. And, it is a neurotoxin, or it is metabolized into a neurotoxin. It can cause this. And so like the way that it works, and again, you have to know it because like you might see a patient with this at some point. And so like alcohols are metabolized in the liver in humans. And so I'm trying to think, it's like alcohol dehydrogenase, I think, is the enzyme that reduces oxidizes alcohol into an aldehyde.
Yeah.
And so once you have methanol going into the liver, then it's oxidized, and then it's oxidized from an aldehyde into formic acid is like the end product. It's the carboxylic acid that's kind of the end product of methanol metabolism. And again, the formic acid is a neurotoxin. It causes acidosis of the blood, and preferentially will cause blindness. And it's really interesting, actually. Another kind of tie-in to MCAT topics is that the way that this is treated, there are 2 treatments for methanol poisoning. And one is a medication called fomepizole, and it is an inhibitor of alcohol dehydrogenase, I believe is what it is. And so it will the methanol itself is not toxic. It's these, metabolic byproducts are toxic. And so you treat with fomepizole and it stops that reaction from occurring. And you can, save someone's vision that way. But if you don't have access to fomepizole, which like lots of, smaller hospitals and kind of community areas don't have, then what they can do is they give you alcohol. They give you ethanol, because ethanol byproducts are they're not good for you, but they're not as toxic. They're not lethal, right? In the acute setting. And so they'll give you a bunch of alcohol, and like I've heard stories of like, people who were out in the country and like they didn't have anything, and so they would just like give a patient like a bottle of tequila or whatever. You know what I mean? So I think ideally you do some sort of like IV suspension of ethanol. I don't know exactly what it would be. But like in a dire situation, you could just like drink ethanol, and it will, competitively inhibit those enzymes, right? Because it's the same enzymes, the same alcohol dehydrogenase and aldehyde dehydrogenase that are metabolizing the methanol and formaldehyde that would be metabolizing ethanol and, whatever the byproduct of ethanol is. And so you like give them all this ethanol, and it will competitively inhibit those enzymes. And that way you don't have, processing and metabolism of methanol, and you don't have, generation of those toxic byproducts. So it's kind of an interesting thing. And, it's, I haven't ever seen that, but but it comes up, it happens, and you need to know it for boards.
The reason I'm laughing almost is like I'm imagining like a Don Julio commercial where it's you got a patient in a hospital and it's like a legit Don Julio like riding in on the horse, just presenting
delivering
this big bottle of alcohol to this patient who just like downs the thing and is like recovered.
Yeah, man.
And
I mean, that's how you treat them, I guess.
Yeah.
Maybe.
Yeah. In theory.
In theory.
But yeah, no, it's interesting though, because like effectively what you're doing is you're saturating the alcohol dehydrogenase with a different alcohol.
Exactly. Yeah.
And just like, trying to
drown out the methanol.
Yeah.
Really.
Yeah. Yeah. I mean, it's really the definition of cutting your losses at that point. Like, it's that's good though. And like I think even there, like there's little connections that people can make. Like the prefix form, for example, usually means one, right? We know like methane is one carbon, but formic, right? Or formaldehyde is one carbon as well. So being comfortable with some of the terminology and connections there, I think is helpful. And I think the last thing we kind of want to get into is, we could have gotten to carboxylic acids, for example, what happens from here. And I think, obviously we need to know our functional groups, and we'll talk about a couple in particular, but what's great about a lot of these, or at least a couple of these, is that they directly connect to biomolecules. I think the easiest way to remember carboxylic acid derivatives is that they are in fact derivatives. So it's always carboxylic acid plus something gives you something else. And so now we just fill in the blanks. If I react to carboxylic acid with an alcohol, and this is where, being able to push electrons can be actually pretty helpful. But even if we just look at the structures, take the alcohol and stick it where the OH is. What do you get? You get an ester.
Ester, yeah.
Right? What biomolecule is that relevant to? Like, where do we see esters body? Well, you got to ask yourself, where do I see an acid reacting with an alcohol? And the answer would be in triglycerides. You have glycerol with 3 fatty acids. Those are ester linkages.
Esterification, right?
Exactly. Not to be confused with its opposite process, saponification. I think that was actually something that really made studying fats a lot easier for me, was just realizing those two things were opposites. Because I was just like, the heck does soap have to do with an ester? But then it's just, you realize that, I'm releasing fatty acids so that the fatty acid tail can trap oils, and then the acid part can get washed away by water. And that's how soap works. Cool.
Saponification.
Yeah. So we've got our esters. We've got, if we react with an amine, right? Again, stick the amine where the OH is. Now you've got an amide. And again, if we think about where would we have an amine reacting with a carboxylic acid, that's a peptide bond, right? That's proteins. And the suffix "ide" in peptide helps remind us that this is an amide functional group. The one thing I'll add about those two specifically, because it has come up a lot on the MCAT, and I know specifically in the context of antibiotics, these are relevant as well. but the cyclic versions of amides and esters, where the molecule just sort of loops back around to like itself and it forms a ring, that leads to the prefix lact. I don't know if lact actually means cyclic, but I would assume so. Doesn't make intuitive sense, but I'm just gonna go with it. Anyway, a lactone is a cyclic ester. A lactam is a cyclic amide. And those are two terms that you will want to know on this exam. And, we hear a lot about, beta-lactam antibiotics, and then bacteria that are antibiotic resistant, will express these beta-lactamase enzymes, which basically break down the antibiotics. And so terminology to be familiar with there for sure. The other two major carboxylic acid derivatives are the anhydrides and just like the acyl chlorides. The acyl chlorides just like and I guess it's a good time to just briefly touch on what an acyl group is. It's basically a carboxylic acid, but the OH group can be anything. It could be chlorine, it could be whatever. Acyl chlorides aren't too heavily tested on the MCAT, but basically the chlorine becomes a leaving group, and then you're sticking on the carbonyl with the rest of the carbons to something. Yeah. There's a question, I believe, on the unscored sample test about acylation. So there's lots of examples out there. Anhydrides are just carboxylic acids plus carboxylic acids. Mm-hmm. And that's really the bulk of it. I think the one other thing to add there is, when you hydrolyze these things, you're just going to get the two things out that you started with.
Yeah, absolutely. I'll just add, I think I don't disagree with you. Like, I think it can be helpful to push the electrons in these situations. And I think the alternative, you could just like memorize these reactions, right? But like when I'm thinking through these things, and I think probably you as well, you're like thinking about the mechanism of like what's going where. And I don't think about it in terms of like where electrons are going per se, but I am thinking about it as in terms of like nucleophiles and electrophiles. So like when we talk about carboxylic acids and like where things are going to react, like that carbon is super electron poor, right? So it's a great electrophile and things are going to react there. Like you're going to have groups coming in and attacking that carbonyl carb or the carboxylic acid carbon. And then similarly, so if you have something else that's going to react with that, then you think, okay, where are the electrons? Because wherever the electrons are, that's kind of your nucleophilic group, and that's what's going to attack that carbon. So like the first one, you talked about like carboxylic acid and alcohol reacting to form an ester. Like again, that carboxylic acid carbon is an electrophile. It's very electron poor. And so where are the electrons in alcohol? They're around the oxygen. And so that oxygen group is what's going to attack the carbon and kind of kick things around so that it can create an ester. And,
right.
I think, again, for me, it's less about like memorizing things. It's less about being too detailed, but more just thinking like where are electrons, because where you have lots of electrons or no electrons, those are kind of the like less stable and more reactive parts of biomolecules. And so that's where you're going to see the most movement and things like that. I don't know if there's like a perfect way to study these things, but just wanted to add kind of like my thought process as I look at these reactions. Hopefully it helps someone to like freak out a little bit less about some of these things.
Yeah. I mean, I think it just speaks to the fact that, this stuff can be learned multiple ways.
Yeah.
And, whatever way works for you doesn't have to be the way that works for somebody else. So, I think it's more so just about, finding something that makes sense to you. And then from there, making sure that, you're repeatedly presenting the information to yourself over time, getting the benefits of spaced repetition, and doing your best to try to understand rather than memorize, I think is always important.
Absolutely.
But really, like, that's what we just talked about is, probably north of 25% of O-chem on the MCAT. And that's a big,
It's a good chunk.
Yeah. And really, like, if you take out tangent discussions, that's like maybe a half hour, right? So I think that just speaks to the importance of being efficient in the way that you're learning information. And hopefully that gives our students and our listeners, a sense of optimism that, hey, okay, like I can conquer O-chem.
Yeah, I think it's doable. It's a tough subject, but I actually really love that you broke it down into 4 categories. I never thought of it in that way, but you're absolutely correct, and it definitely makes it more doable. We got to talk about laboratory techniques at some point. That was like my favorite part of O-chem.
Yeah, I honestly, that was my least favorite part. So
Really?
That works. Yeah, because here's the thing: is I did my O-chem labs during COVID. So I never actually did the lab techniques. It was
Were
just
they virtual?
Yeah, it was pretend this is what you smelled. What acid did you make? I just
the first reaction we did was synthesis of banana oil. I remember distinctly because it didn't work the first time. I had to do the whole thing again. It took forever, but it was like a very definitely a banana oil smell. And those things just stick with you. I don't know. It was a fun lab. That's a bummer you didn't get to do it.
Yeah, no, no, like you can't, like, I get the idea, and like granted, like it wasn't the instructor's faults or anything, like it was COVID, but an O-chem lab online is just not a good experience. But in any case, hey, maybe in a future episode we'll dive into those lab techniques, because they are actually, they're not the most intuitive at times, but I think, similar to what we did today, we can break it down in a way that's easier to understand, and then that's another 20 to 25%. Exactly. But in any case, guys, if you take anything from today, understand that O-chem can be simplified, and it is very doable, as is anything on this MCAT. But efficiency is key, right? If you're having a hard time with the topic, don't hesitate to maybe look at a different resource or consult, a trusted friend or teacher who is knowledgeable on this stuff and can teach it to you in a way that's easier to understand.
Yeah.
All right. Happy studying, everyone. And thank you again for tuning into this episode of the Westin MCAT podcast. We'll see you on the next episode. Take care, guys.